Hello, everyone. Thanks for tuning in to this Duncan Aviation Straight Talk webinar. My name is Eric Anderson, and today we'll be discussing everything you need to know about burn testing at Duncan Aviation. Before we get started, let's take a quick second to meet our burn lab experts. Cliff and Alejandro, thanks for being here. Will you take a second to introduce yourselves?
Yeah, so I'm Alejandro Chavez, based out of the Lincoln, Nebraska facility. Been an interior engineer here at Duncan for the last 6 years.
Cliff Barker. I've been at Duncan Aviation since 1987. Been doing flammability since 1995, so quite a bit of experience there. And I also work in the engineering department.
Awesome. And my name is Eric Anderson. I'm based here out of our Lincoln, Nebraska facility, and I've been in the marketing department for about 3 years now. So let's go ahead and just jump right into this. Cliff, what is burn testing?
Well, burn testing is it's a destructive test by fire to determine a material's ability to withstand propagating a fire, for the most part. And there's multiple different types of flammability testing. They're all required for different reasons, different types of aircraft, different models of aircraft. But it's intended to provide safe materials to be installed in aircraft.
Awesome. So now that we know a little more about it, why do we do it?
Flammability testing is to understand the burn characteristics of a material, is to understand how to prevent it from burning. In other words, we do the testing so that we can see how the materials that we propose to put in an aircraft will do if they're subjected to an ignition fire of some type in the aircraft, and whether or not those materials will continue to burn on their own once that initial spark or cigarette or whatever caused the initial fires started it, if they're able to self-extinguish or put themselves out.
And to put it in simple terms, the reason we do it, it's regulatory. FAA requires it.
And there's that too.
Compliance and ensuring passenger safety.
Awesome. So what exactly are we looking at in this picture here on our screen?
That's just an example of a set of coupons, test coupons. There's 3 setting on top of each other there. So we have to do a minimum of 3 tests for this particular test. And then we do an average of the 3. But that shows the burn length, pretty much of a buildup. Is probably a panel, quarter-inch or half-inch panel with a veneer and a finish coat on it. And the flame was placed underneath that, the bottom edge of that where you see the burning starting. And once the test flame's removed, then we calculate the burn time and the burn lengths and if there's any dripping coming from it. But just an example of one that is probably close to being at the limits of what we would allow to be installed in an aircraft.
Awesome. And we do have a bunch of videos that we're going to show you guys, so stay tuned for those to get a better example of how this works. Moving on here, what type of stuff do we test?
We test everything that goes into the crew, passenger, baggage compartments of an aircraft is required to have some type of flammability certification on it. And some exceptions are like metal parts. Any metal part with less than 10% magnesium does not have to be tested. Metal parts with an organic primer or paint on it, inorganic primer or paint don't require testing. And then there's small parts that do not contribute to propagation of a fire. There's some limitations on those being exempt from being testing, but there's not a whole lot of things that are exempt. It's pretty much anything we propose to install in an aircraft.
And those materials range from stone all the way to any fabric. And even recently, we've been doing a lot of hydro dipping, which is becoming quite popular nowadays as well.
Yeah, absolutely. So we have a pretty extensive burn lab. How does having that in-house benefit our customers?
downtime control is the biggest. One-stop shop, I would say, makes it easy for a customer where nothing is outsourced. We control lead time and all the outcomes of the modification and product that a customer is requesting to be installed in their aircraft.
And we provide the customer with a complete flammability package of test data and everything, and that becomes really valuable in the resell of the aircraft later on down the line for the customer.
Yeah, I think end of the day, it just comes down to safety and the importance of that. No one plans to have, something happen on their flight, but if it does, you want to make sure that all your bases are covered. So we have a number of different type of tests we do here at Duncan Aviation. You can see some of those on your screen. We'll get into each one in a little more detail and have some video examples, but will you guys just talk about kind of the high-level differences of these?
Sure. The horizontal test was an original burn test from the 1950s under the CARs, as they were called then. And that was the original test, like I say, and the first test that was basically required under when Part 25, or I'm sorry, when Part 25 became into existence in 1958. Vertical testing came into effect in 1967, so that's been around for quite a long time. The sonic oil burner is a fairly new test. The sonic is just a type of burner. The original Park's oil burner test, which is the same test requirement, came into effect in 1984. Waste compartment testing, even though a lot of people don't have any idea what that is, it's been around since Part 25 was initiated back in 1958. And so has 45-degree testing for baggage compartment liners and waste compartment liners. That became effective 1958 as well. In-house, we deal with mostly Part 25 rules, and 853 is the one for interior materials flammability testing. Now, there's other things under that rule, but it's the primary one for flammability. 855 is basically the same thing as 853, but it deals with baggage compartments, baggage or cargo compartments. One that's not on that list that we don't do internally, but we do have to do as a requirement is insulation testing, which is a fairly new rule. It came out in 2003 under 25856. And that type of test was developed, and most of these tests have been developed or for some specific reason. For instance, the insulation test was developed after the Swiss air crash off of Nova Scotia in 1998. They determined that was a insulation material that's behind the walls, interior walls of the aircraft, and it was sparked off by a shorted wire and started the insulation on fire. Even though the insulation at that time met all the required vertical testing requirements, they still found that in the application it was in, where it was at, and how it was applied, and maybe some contamination because it had been in there for a number of years, that it allowed that insulation to burn the entire length of the aircraft, burning wires and everything in between, and that's eventually what brought the plane down.
And a couple that are not on that list are 23, Part 23, which is quite similar to 25 that are shown there.
Correct. 23, those are the two fixed wing type aircraft. There's also 27 and 29, which are for the rotor wing type aircraft.
Yeah, so there's a number of different tests that we do. Let's kind of jump into more detail here with the vertical burn test. What are we looking at in these pictures?
That's a vertical burn test chamber. Typical. The picture on the right or on the left, you can see him holding the sample, which is in the fixture holder. The sample is that brown veneer material, and it'll be put in the chamber in a vertical stance. And on the on the right, you can see the flame being applied to it underneath the sample. And it looks like he's getting ready to remove it after the time period it was up for the test flame to be under it. And then we'll start observing from that point for how long it continues to burn on its own.
Awesome. So we have a video here to kind of show this better. Cliff, as we play it, love if you'd walk us through and kind of let us know what we're watching.
Yep. Now see the flame has been applied, and I don't know if this looks like it might be a little slower than actual speed, but since that's a buildup, it looks like it was to be applied for about 60 seconds would be the test. So that test flame will sit under there for 60 seconds to initiate the material to be on fire. And then after, maybe if you bump that ahead a little bit.
Okay.
It's pretty close to that. All right. You see that? Okay, now the test flame has been removed. And you can see it's still burning on its own. This is what we'll be timing, is how long it takes to go out like that. And it has 15 seconds to do that in. If it's still burning after 15 seconds, the material is considered to be non-self-extinguishing. And if that happens on all three samples and the average of all three is over that 15-second limit, then that's a test failure. There's also, once we take it out of the chamber, we'll measure the burn length. And for this particular test, the overall burn length average on all three samples can't be more than 6 inches.
Great. A lot of good information there. Moving on, let's talk more about the horizontal burn test.
Okay, like I said originally, this is the original test for most all aircraft back in the early 50s. This is the only test they were doing, actually. And it's just, like it says, you set your sample in there horizontally. You can see it in the test fixture on the right there. The blue material is the material, the fabric being tested. And on the left, you can see it's behind a glass door, and so we can observe it. And then the Bunsen burner will be placed at the beginning of it and starts it up. And it's a little bit different than the vertical test, because the vertical is we're looking for self-extinguishing, whereas a horizontal test is a burn rate test, where we're looking to see how quickly the material burns across the horizontal plane. And there's some starting points and timing period areas in there that will come up in the video next. But let's play that and I'll explain that there. All right, you can see the test flame down at the bottom. We're moving it in. It starts out at that first pin that goes across. That's the starting pin. We'll apply the flame for 15 seconds. And then the test doesn't actually start till that flame front reaches that second pin. Then we'll start timing it, and then it's 10 inches from that pin to the pin at the very far end, and we'll let it burn that entire length, timing it. And what we're looking for is either a burn rate that's 2 inches per minute or less, or 4 inches per minute or less. I'm sorry, it's 2.5 inches or less and 4 inches or less. And if it burns faster than that, depending on which one you're doing, then that's when it would fail the test. If it goes out before it reaches that first pin, then it's a 0. And if it goes out before it goes from the starting pin to the final pin at the other end, if it goes out any time in that period, it's also a 0 test.
Awesome. I'm going to fast forward here a little bit.
You can see it gets it into there, and I think it does. This particular one, I think it does go out before it reaches the other end, but it's a time-consuming test for, if nothing else.
Oh, yeah, yeah.
Unless it's a poorly treated fabric, and then it burns fairly quickly.
Yeah, so you guys get the idea there.
Yeah.
Let's move on to my favorite of the test, the sonic oil burner test.
Right. Now, that's the newer name for it. Like I said earlier, it's basically an oil burner test is what the technical name is for it. The sonic is just the design of the burner apparatus and stuff over the old Parks oil burner, which is basically a home house oil burner unit that's been converted into what the FAA needed back in the '84 when they first developed this thing, but now it's been upgraded to the sonic burner. But basically, it's for testing aircraft seat cushions. And the point there is we want to be able to show that seat cushions, once they catch on fire, that they don't continue burning and putting off unburnt gases, which collect in the aircraft and initially, after a few minutes, become an explosive combination. So let's run the video on that one.
Yep.
So you see here the test article. The seat cushions are going into the flame. The flame is about 4 inches away from the edge of that test cushion, and the temperature of that flame at that distance is about 1,700 degrees. So it sits on there for 2 minutes, and then once the 2 minutes period up, the cushion will be removed from the fire. The flame will be turned off, and the cushion will be removed from the heat of the burner cone. And there are three things we're looking for. Is one is weight loss, the other is a burn length across it, and there's not necessarily a burn time involved here at all, because once it's removed, it can continue burning for up to 5 minutes afterwards. But what we're looking for is once that flame goes out, then we could take a weight reading, because we already took a weight reading of the unburnt or of the cushion prior to the test, and then we'll take a weight reading after the last flame has gone out on it, or at the 5 minute mark. Then we're allowed to put it out and take the readings. But we'll take that reading, and that'll give us our weight loss percentage. And it can only lose no more than 10% out of the 3 sets we test for this particular test. There's 3 cushions we run the test on, and then we do an average of that material. But can't have more than 10% weight loss. And there's a maximum burn length also for the back and bottom cushions on this particular test.
Okay, I'm gonna go and fast forward a little bit. Oh.
Yeah. Now you can see it's out. It's still kind of burning on its own. There we go. Now you can see it's still burning. We allow that to burn up to 5 minutes after we've removed it or turned the flame off. And but as soon as it goes out, then we can start taking our readings. But what we're looking for is the lack of smoke that's being generated or unburnt gases that are coming out of that cushion. And they determine it by calculating the weight loss based on the BTU output of the flame and what the materials are and stuff.
And did this seat pass? Do you remember?
Yes, this actually passed the test. This is a good test.
Awesome.
I think it had, this particular one had like a 6% weight loss.
Great. That's what we want to see. Let's move on to our last test that we're going to talk about today. Is the waste compartment testing.
Yes,
And, why is there? That looks like just a typical waste basket. Why is there a big X over it?
well, this is a, if you ever have an FAA inspector walk into your aircraft and he asks you what this is, you tell him it's either a puke bucket or your owner likes to put his foot in it to soak his bunions, because it is not a trash compartment. That is a fire hazard in and of itself. So if we go to the next photo, well, it'll show next screen. It'll show the correct type of fire waste compartment that is in an aircraft. And I say that because a waste compartment in an aircraft has to be certified to be able to contain a fire within the compartment while it's closed, and also has to be able to self-extinguish it, or rather, actually, that the test material you see there can completely burn up inside that compartment as long as it doesn't escape through or burn through any of the openings, come out of any gaps, or burn through the sidewall altogether. So.
Cool.
That's
Go ahead and play a video here.
Yeah. You see the technician comes in and has a pre-lit piece of paper already, and he'll set on fire 50% of the top surface of that material to begin the test. And once he has about a 50% coverage of that material, close the compartment. And the test timers will start now. And what we'll look for is a peak. So you can see the thermocouple going in the sidewall there if it stops going out of focus. And we'll take a peak temperature, which usually runs anywhere between 600 to 700 degrees. And we'll watch for that peak, and then we'll gradually watch it drop in temperature. If the compartment is containing the fire, it should be suffocating basically because of the smoke and lack of oxygen because it's burning oxygen off inside there. And we'll watch it, and the test ends once the temperature inside the compartment drops below 150 degrees. Or if you open it back up and it reignites, then you continue the test until it goes out again and drops below the temperature again. But there is no requirement for the amount of smoke that can be coming out of it, but you don't want to see any flames coming through gaps or openings. And that's why a compartment has to be built correctly per regulation requirements so that your gaps are tight. If you can't get tight gaps, you need to put seals in. So you don't have, you're limiting the amount of oxygen that can get to that fire.
So did this waste compartment pass the test?
Yep.
Do you remember?
Yep. I've only had, since I've been doing it since 95, I've only had like 2 or 3 that have failed.
Awesome. And that's why you're the expert.
Yeah.
And what's important from all these videos is all the tests are specified and controlled. So even going to the media that is in that waste compartment is specified and controlled.
Right. That's an exact FAA required trash that's in the compartment there for the NFA process.
Awesome. So we have a whole new and expanded burn lab at Battle Creek. Tell us a little bit about that.
Well, it's a new lab. We just got possession of it from the contractors back in May of this year. We've been running most of our vertical testing up and everything, but we had to wait till the contractors were done before we could start building and putting in our sonic burner. And we just got that up and running last September, and we've been running preliminary testing on it and some functional testing for tweaking here and there, but it's completely up and running now, and we have plenty of room for expansion to other tests like insulation. We plan on bringing that in within the next couple of years, and a few other tests down the road, and also testing that has nothing to do with flammability.
Great. We're going to kind of change the direction of this. And Alejandro, will you talk to us a little about the engineering side of burn testing?
Yeah, so before we even talk about burn testing, there's the role of the customer. The customer specifies what they would like performed, what modifications, whether that's new seats or reupholstering a seat to existing seat frames, or they want to come in and install monitors, so on and so forth. Engineering takes that modification and they specify the materials. And what we typically do is we're quite good at what we do, and we specify materials that will perform well in all aspects of the mod, whether that's structures or strength and flammability. So from fabrication prints, the test articles are representing the modification. So to the test you saw earlier, that veneer with the panel, that could have most likely been a bulkhead with a monitor being installed that we're representing. Same with the seats, so on and so forth. And each step of the way, before we do any testing, the test article has to be approved by the FAA. And then so from approval of the test articles, a plan is then written. The plan explains how an article will be tested to meet a certain regulation based off the aircraft's certs. So how an aircraft was certified is how an article will be tested and where they're used throughout that aircraft. Once articles have been tested, It goes back to engineering, and engineering writes a test result explaining the outcome of each article, whether that's a failure, whether that's a pass. From there, you once again have to get it FAA approved. So the constant saying is, no matter what you do, it gets approved from building to testing to certifying. It all touches the hands of the FAA approval at some point in time.
Great. So to kind of wrap up the webinar, whenever talking about burn testing, there's always a couple of questions that come up. And the first one is, what if an item doesn't pass the test? What happens?
Well, there's a couple of things that need to or can be done. First thing would be to evaluate the application. How is the material being actually used in the aircraft? For a lot of times, we'll have the information will be that it's a part of a divider wall, and that requires a 60-second test. Well, if we get down into the details a little bit more, it might be a part of the divider wall that doesn't require the 60, it only requires a 12-second test. So if it failed the 60, we might be able to do the 12-second to show that it meets that requirement. Evaluate the sample for why it did fail. What was the failing component of the test sample? If it's for instance, if it's a veneer where it's got a clear coat finish on it, and the finish was burning or the veneer was burning, we may be able to increase the fire retardant that we put in the finished product to then get it to pass. Those are called as installed conditions that we have to maintain. There's also other things that fall under the as installed would be sometimes we got a particular foam that we use that if you test it by itself, it fails. But as soon as you combine it with anything like it will be in the aircraft, it does just fine now. It'll pass just fine. Fabrics, for instance, if we get a failure on a fabric, typically the best solution there is to send it back out to have more FR treatment applied to it. There are some fabrics that just won't pass, no matter how much fire retardant you put on them, and that's when we had to start looking for other alternatives.
And this is a big key of the advantages of having an in-house burn lab. When we do testing, we're most of the time ahead of production and finish, that should we have a negative result, we can adjust quite quick on the fly without any impact to schedule.
Correct.
Great. And that last question we have on the screen, I know earlier we said that pretty much everything gets tested before being installed in an aircraft. But what if a customer has a specific coffee maker that they want installed? Would that have to get tested too?
These are like if it's your Keurig from your house that you're wanting to install onto an aircraft, these are considered COTS equipment, consumer off-the-shelf equipment. A lot of things go into making a coffee maker an aircraft part. That's what makes your Keurig $100 and a TIA coffee maker maybe $10,000 or somewhere in that range. There's a lot of certification that goes involved just aside from flammability that requires a lot of safety and can impact the aircraft's electrical system. And even in some point, if you have a glass carafe for that coffee maker, you could now have glass in the cabin rules being affected, which all comes into play when you install COTS equipment.
Great. So let's go ahead and wrap up the webinar. I'm going to put these guys' contact information on the screen. If you guys have any questions regarding the process, requirements, please don't hesitate to reach out to them. If you guys have any questions regarding the Duncan Aviation Straight Talk webinars or podcasts, please shoot me an email. I'd love to see what I can do for you. Cliff and Alejandro, thank you for taking your time and joining me today.
You're welcome.
Thank you, Art.
Awesome. Just a quick overview of Duncan Aviation. We're the largest family-owned maintenance, repair, and overhaul facility in the world. And as you can see on the screen, we really are a one-stop shop. We have 3 full-service facilities based out of Provo, Utah, Lincoln, Nebraska, and Battle Creek, Michigan. If you guys liked what you saw today during this webinar, I invite you to check out our website at duncanaviation.aero/resources. From there, you'll find all of our past webinars, our podcasts, fact sheets, videos, galleries. So there's a lot of awesome stuff there. So I invite you guys to check that out. All right. Thanks, everyone.